paper to provide the subsidy of electric vehicle industry. The author used the system dynamic model which contains three modules. I will discuss in further slide about this, and the author also used the different cycles like business cycle and generator life cycle. The outlines come from this paper's abstract introduction, literature review and theory, research question, research methodology, analysis, discussion and conclusion. The keyword in this paper used is electric vehicle government subsidy scheme, CO2 emission reduction, subsidy efficiency, system dynamic model. And the abstract and the basic objective of this paper, using empirical evidence from China, verifying the proposed model and predict that both on acquisition subsidy and R&D subsidy. R&D stands for research and development subsidy, can boost EV demand and reduce CO2 emissions. Method: the acquisition subsidy helps to stimulate the sales of EV more quickly and to greater extent in the short term, but at great expense for a given level of government expenditure. The R&D subsidy is more effective in promoting EV penetration and mitigation of carbon dioxide. An alternative to ICVs basically consist of petrol vehicles, which is the cause of some kind of air pollution. So we can say the alternative to ICV, electric vehicles, EV, has been regarded by many countries as a key way to address global warming, given that a growing proportion of electricity is generated from renewable sources. There are two types of subsidy scheme for the EV industry acquisition. That is very important point. The acquisition subsidy and research and development subsidy. The acquisition subsidy is provided to consumer when they buy an EV, and R&D subsidy provided to manufacturer to encourage them to exert more effort in EV technological innovating. These subsidy schemes can be either static or dynamic. A static subsidy remains unchanged over the period, while a dynamic subsidy changes in the value over time. Such question, a series of such questions arise taking account of the interaction between government, manufacturer, and consumer. First of research question is, what are the effects of a static, dynamic acquisition subsidy and R&D subsidy? Which one will be better? Which one will be better able to achieve the target for EV adoption set by the Chinese government? The third one is, given the same subsidy budget, which type of subsidy is the most efficient? Now come to the motivation of the introduction theory. To address these questions, we use a system dynamic model to capture the dynamic interaction between government, manufacturer, and consumer, and take China EV industry as a case study to examine the effect of different subsidy schemes on the development of the EV industry and on environment protection. The finding helps to develop a holistic understanding of EV system and will be of great help in the formulation of scientific subsidy scheme that promote the development of the EV industry on the basis of the changes in the decision-making behavior of consumer and manufacturer at different phases of EV development. Introduction: the paper contains the conclusion of the study. Literature review and theory: it is evident that a substantial amount of research has been done on government subsidy in the EV industry. However, these studies neither portray the dynamic interaction between different types of government scheme, manufacturer, and consumer. This is the one already done in this before this paper in the shape of case study, but in this case study they did not find out the problem, what the actual problem to foresee method by the government, nor examine the effectiveness and efficiency of the different government schemes with the use of real world data. They therefore failed to inform the choice of subsidy scheme from the government standpoint. To overcome the research gap, this paper uses a system dynamic model and empirical data from China to study the effect and efficiency of different subsidy schemes in relation to EV penetration and CO2 emission reduction. The main contribution of this study are threefold. First, by using an ST model, this study analyzes the decision-making behavior of the government, manufacturer, and consumer in the EV system, and then takes account of the dynamic interaction between them to better describe real-world situation. Second, we consider the effect of two types government subsidy scheme on EV sales and CO2 emission reduction using scenarios, simulation, then extend the analysis to compare the static subsidy against dynamic subsidy as there is a fixed subsidy budget by the government. The third one is two objective for the government when selecting the optimal subsidy scheme and introduce subsidy efficiency regarding environmental improvement. This study provides a more holistic understanding of EV system and insight for policymakers seeking to design an effective green subsidy scheme. This is basically the model as I discussed in the start of this presentation. The ST model, system dynamic model, contains the three modules, and this is the basic pillar of this paper theory. The government module, the manufacturer module, and the consumer module. Under the paper to provide the subsidy of electric vehicle industry, the author used the system dynamic model which contains three modules. I will discuss in further slide about this, and the author also used the different cycles like business cycle and generator life cycle. The outlines come from this paper's abstract introduction, literature review and theory, research